Hey guys, no unit on water is complete without talking about the pollution that we put in it. Dun dun dun. So by definition, water pollution is any change that changes the quality of the water. So makes it either possible to harm organisms or makes it unusable to humans. There's two types, and I really want to make sure that you focus on these because these are going to be tested for sure. The first is point source. Point source is something that literally I could say, oh, there it is, and point to it. That would be a point source. So it's going to be something that's direct, drain pipes, factory smokestacks where it's coming out directly into the air. Those are kind of examples like that. So drain pipes are a great example of water point source where it discharges the pollutant directly into the water. So a pipe that pours directly into a lake or into a stream or something like that. On the other hand, non-point source is a little bit different, a little bit harder to track and to hold people accountable for because it is a broad, diffuse area of pollution. So when we say point source versus non-point source, today in class we did the watershed walk where we went around the campus. So you got to see some drain pipes and things like that. But you also got to see the sloping area. So the hills sloping behind the football field and behind the baseball field. And those areas slope down to the stream. Anything that happens in that area is likely going to be ultimately concluded as non-point source pollution. So it's going to be pollution that's kind of running off from the parking lots and stuff and getting into the stream that way. So it's kind of hard to track it. You can't say, oh, that car emitted 50 grams of oil, so we have to find them. It's a lot more difficult to do that than it would be to find a company that was actually doing point source pollution. So those are kind of the difference between them. I have a diagram here as well that kind of can help you to understand a little better. Top 3 sources of water pollution in the United States and really around the world, but specifically the United States, is as follows. Number 1, agricultural activities. One of the biggest things that pollutes our water is agriculture, and agriculture meaning farming in some fashion. The number 1 type of pollution that we get from that is going to be sediment pollution. So sediment pollution basically adds silt or clay, and it makes the water cloudy, essentially. Okay. Other things that could happen, you could put in fertilizer. Fertilizer would spike the nitrates and nitrogen, which would cause extra growth of plants and stuff, which could be good, but not if it goes too far. Pesticides, that's not good. Pesticide is something that kills pests. Fecal bacteria, well, let's just be straight up. That comes from feces. Okay, so bacteria from poop. So that would come likely from cows or pigs or something like that. Other salts and things like that could also occur. Usually they're going to increase nitrates in the water, which are fine in small quantities, but they could be very dangerous in high quantities. Industrial facilities release a lot of inorganic and organic chemicals. Inorganic means things that are non-natural, mostly man-made. Organic are things that maybe they're man-made, but they're carbon-based, so they come from carbon and they come from life molecules, if you will. They can have various effects on the water, but overall they generally are going to cause death or developmental changes, so they could cause organisms in the water, fish and other things, to not be able to reproduce as well as they're supposed to. Mining is another one. We've already talked a lot about mining. We talked about acid mine drainage, which is this one right here in the middle. And we know that acid mine drainage, of course, is going to lower the pH because it's an acid. Okay, and acid mine drainage comes when you expose things from underground that were locked away. Now they're on the surface, so it could be toxic metals, and those toxic metals could run off, or it could be sulfates and stuff that can lower the pH when they react with water. Okay, this slide, there's a lot on here and it's kind of overwhelming, but I'm not going to go through a lot of it. But what I would like for you to do is just what it says up at the top of the slide. I want you to make note cards on these, okay? On the front side of the note card, I want you to put the type with its effects. Let me change that color just so it stands out a little bit more. On the front side, so put this on the front. And on the back, put these 2 columns. Okay. If you don't have note cards, then do them on a paper and just, with 2 columns, and then you can cut it, fold it, and then you have a note card. But I would like for you to do that so that you can learn a little bit more about the different things that can actually affect water pollution. Ignore any chemical formulas like these. I don't want to freak you out like that. But overall, just kind of understand a little bit more about what these things are. It is possible that you will be asked in the future to be able to separate things into these categories or kind of explain what are some of the major drawbacks of certain categories. A lot of them are logic, so use that in your head, but try to do what you can with those on some note cards. So anything that comes from fecal matter or food waste or anything like that can easily become an oxygen-demanding waste. Oxygen is, in water, a very important factor for organisms to survive, for fish and other things to survive. So if you spike these oxygen-demanding wastes, so if they increase, then oxygen will fall because bacteria are going to eat the substance, use oxygen to kind of break it down, just like we do. We breathe in oxygen to help us break down stuff, and that's going to lead to an overall depletion of the oxygen. Well, you may say, gosh, that really sucks for all those animals and plants that live in the water, but at least it's not me. Oh, you wanted a twist? Okay, so groundwater pollution, of course, we draw our water from groundwater. Here in Highlands Ranch, a lot of our water actually comes from reservoir water, which is surface water, which can be subjected to all those other things we just talked about. But groundwater can be affected in a different way, and a lot of humans actually get all of their water from groundwater. Pollution leaks from landfills, from agricultural land, and other things and percolates through the water. Of course, it needs to be over permeable, P-E-R-M-E-A-B-L-E, permeable materials, meaning soil, rock, sand, etc., so that the water can actually get through. Groundwater then becomes contaminated. In some cases, it's permanently contaminated, and the aquifer has to be abandoned. We can no longer get water from it. And there are multiple aquifers in the United States that have been shut down because of that reason. So we talked about in a watershed how everything flows towards a water source. Well, all of those water sources flow towards bigger water sources, and all of those water sources ultimately flow to the ocean. Okay, so pretty much everything we do in the United States ultimately can end up affecting the ocean at some point. And we forget that things flow downhill, and they're going to continue to flow down to sea level and continue to do that. Ocean currents then can transfer things all over the planet, and on the next slide we're going to talk about some of those currents again. So just to refresh your memory, there are what we call these gyres. So any sort of pollution that may, let's say, run off from California into the ocean. Not only is it going to affect the water right off of that location, but because of these currents, it's going to draw it all the way around. So now it's going to affect places like the Philippines, X, the Indonesia and Malaysia, X. It can continue around and affect places like Japan and China. And then it could continue around, and even if it hasn't been absorbed by something else, affect places like Alaska and the Pacific Northwest. So these gyres move this pollution all the way around the planet. And as with most spiral things, as you continue the spiral pattern, things start to get drawn to the middle. One of the biggest things that's drawn to the middle in the Pacific is garbage. Yeah, garbage. So a lot of this garbage is stuff that just kind of blows off the beach and ends up in the ocean, but it coalesces or kind of comes together in these locations. But there are still locations in our country and in other countries where they fill giant boats and they take them really far out to sea, and then they dump all the garbage into the water, and then they, I was going to say swim away, but they don't really swim away. They would boat themselves away. Whatever. So that still happens in our world and in our country. This is what we call the Pacific Garbage Patch. I don't want you to memorize a lot about this, but I want you to realize that this is a major, major event that occurred because of this kind of coalescing, if you will, of stuff. We've gotten these two major sections of garbage. Oh, that looks like a face. It looks like a polywag. Anyways, you get these two major areas of garbage that have kind of come together, mostly plastic, but also paper and other things. And you might say, pish posh, who cares? Well, he cares. He cared. He probably cared at some point, but now he doesn't because he's dead. And look at this guy's face. He cares. Okay. So anyways, up here in the top left corner you see that what appears to be a lobster that ingested cigarette butts, and it completely has blocked its entire digestive system, so it no longer is able to do anything and ultimately died as a result. We see a lot of this. We see strangulation, especially when a small animal gets it and then grows up over time. This would be a fishing net of some sort that was left in the water, and he's clearly very upset about it, so that's understandable. This is oil pollution, likely also coming from an oil spill or coming from some sort of runoff from a beach. And then this is what a lot of the garbage patch looks like. Some of it is large garbage that you can actually see floating on the surface. Others are really, really small particles of plastic which animals can actually ingest, and that can kill them as well. So just because I have the opportunity, I wanted to talk a quick moment about decomposition of stuff, so plastics and things like that. This is a really interesting slide. I recommend you pause it and just kind of look over some stuff on this. It kind of talks about how long it takes for these things to break down over time. So even just a simple styrofoam cup, it takes about 50 years for the ocean to break it down. So if it ends up in the ocean, it's going to be out there for about 50 years before it ultimately gets taken down. And then glass is undetermined. Glass does not decompose. And it doesn't corrode, and it doesn't react with anything in the ocean. So glass essentially can stay around for almost forever, as far as we know. Other things like paper and whatnot are going to break down in a lot faster time. But just kind of get you into that idea about talking about pollution and how it isn't something that can just go away. It's something that you may have to see for a very long time, perhaps, I don't know, 400 years. All right. Hope you took some good notes, and I will see you guys in class.